Assalamualaikum warahmatullahi wabarakatuh. I want to present our project presentation, which is recurrent neural networks configurations in the predictive maintenance problem in aircraft predictive maintenance. These are our group members, which are Zawawi, kemudian Adam Airil, and myself, Ahmad Auf. A little bit intro of our project is the case study in the article that we choose is about the use of recurrent neural networks, or in short RNN, for predictive maintenance. The article describes how RNN can be used to forecast the remaining usable life of aircraft engines, which can help to avoid unanticipated breakdowns and increase safety while saving airline monies.
Thank you all for the introduction earlier. Hello Prof, my name is Muhammad Zawawi bin Ismail, and now I will continue with the next part of our presentation. I will now give explanation on the sample data that we use in our project. So we obtain this data set from the Kaggle website, in which I have placed one hyperlink that will direct us straight to the website. And the name of dataset that we use is Aircraft Predictive Maintenance dataset. So for your information, this website show us a lot more than just dataset. It also has some information regarding the dataset, some illustration that tell us what is this dataset all about, and of course some coding for the dataset. But for our project, we will only use the dataset. And here is the dataset that we use. For this dataset, you can simply download it by just clicking this download button. But for me, I have already downloaded it into my computer, so I have no need to download it again. But I will just show you the dataset that we use. There are two types of the dataset. The first one is the train set, and the second one is the test set. Just like how the name goes, both of the dataset will be used in training and testing process in our project. So for both dataset, it contains three type of data. For the first column, it contains the ID of the aircraft, and from second column to the fifth column, it contains the setting information of that particular aircraft, in which the setting may be differs from one aircraft to another. And lastly, from column 6 to column 27 contain the aircraft sensors information. Okay, that is all about the uh, dataset information. Now I will simply go to the next slide for learning and analysis process. So in our project, we use long short-term memory, or in short, we can call it as LSTM, as the method for the learning and analysis process. So what is LSTM? It is type of recurrent neural network that learn by being trained on a dataset of labeled data in, or we can also call it as supervised or guided learning algorithm. So the data is presented to the LSTM in a sequence, and the LSTM learn to predict the next element in the sequence. So for this case study, the data that used in LSTM is the ID, setting information, and lastly is sensors information from the dataset. So for the implementation to the data set, I will hand over the presentation to Hakimuddin.
Okay, I will continue on how the analysis is conducted in our projects. And to implement that, we are using MATLAB codes in our models. As in the MATLAB code, we separating the data into train set and test set, which means we only using 1389 column, row, 1,389 row, means that in all we are using all these data sets here, and we are using to predict the total of RUL, which will be on the last column. As we can see here, EAA, and the last column which will consist of AA 1 3 4 8 9. Okay. For the input size, we are using the same as our train, which will be we have 1,388 feature, and for the number of response, we also 1,388. For the number in the units, we are using 100s, and this is the codes for implement the LSTM layer, and we have 4 layer which will including sequence input layer, input size, LSTM layer, number of hidden units, fully connected layers, number of response, and decision layers. For the options, we have training option. We'll be using Adam as our optimizer. Mesh as epoch, we set it to the 1000 to the limits, and the guidance threshold would be the 0.01, and the initial learn rate would be the 0.0001. For this is the codes to implement this train network, and this is the code to predict the result, which be the test result. To evaluate our codings, to evaluate our projects, we are using mean square error because this project is regarding to the regressions, in which we only can predict evaluate this based on the mean square error. So we are using calculation of the root mean square error and the R squared error. Okay, for the result, we have this is the result of the performance. Based on the result, there is some of the prediction values that's almost reached on the outcome, expected values, and as we can see here, it's quite messy compared to the output values. And for the next, we move on to the output on this MATLAB. So we have 5 types, which will be epoch, iterations, time elapsed, mini batch, RMSE, which stands for root mean square error, and mini batch loss, and the mini batch loss, and the base learning rate. For the base learning rate, as we can see here, we are using 0.0001. So the approach is set to this 1000 as a max, and as we can see here, the mini batch root mean square error decreasing over time, but it stopped at 512, which means it's lower than 1000 when the first one. So this is the predictions of our projects. And lastly, this is the result of the root mean square error and this coefficient of determinations. For the root mean square errors, it is 20.1955, and the R squared error is negative 0.8244. For root mean square errors, it has slightly worse results since it does not almost close to the zero. And for the R squared error, it has slightly close results since it is lesser than zero. So for our projects, we can improve our project by maybe increasing the number of hidden units, since we are using too many features. So maybe I can lower it to in order to increasing the root mean square error accuracy, and the gradient threshold I can also increase it in order to have a better result. And lastly, the epoch it can be increasing in order to have a better result.
Okay, next, I will jump to the project's conclusion. Okay, by using the LSTM or long short-term memory technique, all the problems in aircraft predictive maintenance can be solved efficiently, which is, we have seen before, the program have trained and tested the data so that we can detect which component or the machine might have a failure or not. If the RSME is lower and the R squared is in higher value, that resulted that the machine is going to be okay. But otherwise, maybe the machine is going to be failed. Okay, so it can be used to forecast the remaining usable life or RUL of aircraft engines, which is it can help the engineers to schedule maintenance before the machine fails. So, we have to predict which component or the machine might be have a failure or not. So we can schedule it first, where the engineers can maintain the machine before the machine really get to the failure. Next, the engineers can reduce costs, which they can identify the components that are nearing the end of their life. So they don't need to replace a lot of components inside the aircraft, but we can detect the particular component that have to be replaced only. And the last one is we can help to improve safety by preventing the accidents. So the engineers can identify machines that are at risk of failure. So maybe one component might have a really little failure or broken in the particular time, but maybe it can be worse next time or in the future. So why not, by predicting the maintenance earlier, it can help the engineers to prevent the accidents of aircraft to be occur. Okay, so that's all from our group. Thank you.